There is an interesting way to transmit and receive data by using the power outlet. It is called power line communication, or PLC for short. There are many different applications for that, such as intercom. So you can speak with your family in different rooms over the power line itself, or sharing the internet connection to the second floor without using Wi-Fi. You can also use it for home automation to switch on and off different appliances anywhere in your house. I found this PLC module on AliExpress and I got 2 of them. You need at least 2, one as a transmitter and the second one as a receiver. So why we need power line communication when we can use Bluetooth or Wi-Fi? Because anybody can jam your Wi-Fi or Bluetooth signal from distance from outside your house. But when it's come to power line communication, it's more difficult to jam. If your house made by concrete, it can weaken or block the Wi-Fi signal. So this is why you have to use power line communication. These 2 pins goes to power line. Which one live and which one neutral doesn't matter, but it's better to repeat the same sequence for the second module. The high voltage side of this module is completely isolated from the low voltage side. So as you can see, I can touch the low voltage side without getting shocked. And this is very important to protect your microcontroller from getting damaged. As the first test, I used Arduino to send the word hello over the power line. So this is the transmitter. It has a power supply to convert the 220 volt into 5 volt. The receiver has no microcontroller, only FTDI to connect the PLC module to the laptop. You don't need a power supply here because the 5 volt is coming from the USB port itself. I used ferrite ring to filter out the noise on the receiver side and the transmitter side. Connect the receiver to the laptop and open the serial monitor. You can see a lot of noise from the power line pops up on the screen as a question marks. But see what happened when I connect the transmitter to the outlet. I'm getting the text with 2 seconds delay, just like the code says. I was trying to see the data being transmitted on my oscilloscope, but I can't see anything except the 50 Hz mains voltage. The FFT function shows harmonic at 120 kHz. And that makes sense based on the datasheet of the module. I used here 5 LEDs with different colors, so I can turn them on and off by using the serial command. So red on, switched on the red, green on, switched on the green, and so on. If you use relay instead of LEDs, you can switch on and off 220 volt appliances. This is called home automation. It's so important to use a filtering circuit like this one for noise reduction. By removing the filter, sometimes the project stops working. You have to use this filter for both the transmitter and receiver. And the last project that I made by using this module was a pager. So I can write a message in here and by hitting the enter, it pops up on the LCD. You have to start and end your message by 2 brackets. Before using this method, Arduino was showing any noise coming from the grid as a message on the LCD. But now it ignores anything except what is inside the brackets. I added a buzzer to this pager to get a sound notification every time I got a new message. The maximum distance of this module according to Google is 1.5 kilometers. But in real life it's not gonna be that much because of the noise coming from your appliances. I tried to use this module with DC power line instead of AC power line, but it didn't work. Because the model number of this module end up with F, which means it can work with only 110 or 220 volt AC. If you want to use it with DC power line, you have to buy the model that end up with E or K. You can find the code and wiring below in the description. Please like this video and subscribe to my channel. Thanks for watching.